Okay, this is 10.8, the object superclass. Remember that every class inherits from object. Object is a superclass of every class, regardless. You won't have to write extends object or anything like that. Everything is a subclass, and therefore there are three main methods that we'll deal with that the object class has. ToString is the one we're going to deal with the most, overriding that. The second one is equals, determining whether two objects are the same. ToString is a string type. Equals is a Boolean, that is a true or false, are they the same? And the last one is the clone class, that is making an object type of making two classes a mirror copy of one class and cloning it and having two of them. So ToString is the one we're going to use the most. Like we said, that's going to be providing information about a class, hopefully using, providing some sort of information about all of this instance fields in a class. So if I had a rectangle, and I made a rectangle called box, and I gave it two parameters, so position and height width. So I make a new rectangle, I'll go 5, 10, 20, and 30. So x is 5, y is 10, width is 20, and height is 30. And then I made a string, call it s, and we're going to set it equal to box.toString. And what it would print to the screen would be the following. It would print java.awt, rectangle, and then the x equals 5, y equals 10, width equals 20, and height equals 30. This is what this is what string currently equals. It's not, you could print this to the screen, save it, do something else with it. Yeah. But this is because rectangle class has overridden the ToString of the object class. A rectangle inherently does not know how to create a string that looks like this. Now, if I was to make a bank account class, and then try to print or make a string of using ToString, we didn't override ToString in the bank account class, so it's going to do something a little different. So if I had a bank account, we'll call it X, and I'll just make a new bank account with an initial balance of $5,000. Then again, I'll make my string, and I'll set it equal to x.toString. So string s equals x.toString, and then I could print or whatever. But if I were to print s, so system.out print, print line s or whatever, or do something else with it, it's going to do something kind of funky. It's going to say bank account, which is the class name, then the @ symbol, and then a bunch of letters and numbers, something like this, like D24606BF or something like that. That's what S currently equals. Now the numbers will be different. And what this is the object class. If you don't specifically tell a class how to override ToString, it prints the class name and then what's called the hash code. And the hash code is, which we'll do in chapter 16, is a way to uniquely identify objects based on a number system. So you give everybody a unique number, and then you can put into an array and find them a lot faster than if you're trying to search for them by the object type. So if I were to look at ToString in the object class, notice it returns get name. Oops, can't underline. So it returns the class name plus the ampersand plus the change the hexadecimal code to a string, and that's what I'm going to get. So I'm going to get the string representation of the integer value from the hexadecimal hash code of the object, which for our purposes is not worth a whole lot. Now if I were to go to the rectangle class, notice the rectangle class overrides ToString. ToString says overrides ToString and class object and returns a string representing this rectangle object's coordinates and sized values. So in the rectangle class, toString has been overridden. So looks like, so this will be how I get my x equals 5, y equals 10. It's just a string, says return, java.awt, etc. So how could I make a bank account toString into something useful? Well, what I could do is I have to override toString because currently I haven't, so I just inherit from the object class. So it would be public string toString, which is the class header from object, no parameter. And I want to give myself, you want to like show the current value of all the instance fields. So the current state, right? And that's the value. So I would return maybe the string bank account, which is the class name, and then plus the value or something. But I probably want to actually, so we'll do bank account, and then the name of the instance field, because it's not, we know it, but nobody else might. So balance, so the string bank account balance equals plus, in this case, get balance method, and then that would be enough. That would return my instance field balance and its current one, which is much more useful than the hash code of the object. So the next method that we're going to work with is the equals method. Right, and like I said, this is similar to compare to for the comparable interface, except it's only because we back true or false, and it's very different from, for instance, x equals y, which if x and y are objects, just tests whether or not x and y have the same, refer to the same object. That is, I have an object and x and y both point to it. Remember, an object variable merely is the reference to the address. So I can't really use double equals. That's a test that I have no use for. So I have to use I'll override the equals method and use that. We've already used that with strings. Strings can tell if they're equal to each other. So something like if coin1 equals coin2. But currently they don't really know how to check that. The object class equals is rather vague and generic and doesn't do a whole lot for me. It tells me what it needs to do. So equals method, I have to have a parameter, an object parameter, the reference to the object that I'm going to compare to, and I have to return a Boolean true if this object is the same. So now I got to figure out how to do this. Well, just because they have the same value, now technically a coin should have the same value and the same name, but I need to check all my instance fields and see if they are the same. So we'll have public Boolean type, so public Boolean equals, and then the parameter object other. The reason being, again, so this could work with anything. That's why the parameter is an object type. And then just like in the comparable interface, I need to get that other back into my original type. So coin other equals, I got to cast my object other, so I should probably change the name. So let's make other coin instead, just for simplification, because if I just say coin other, that's going to be a bit of a mess. So we'll say object other coin, and then coin other equals, and then cast other coin parameter back into a coin type. So coin, in parentheses, other coin. So now I have my coin other, and it's actually a coin this time. And I can check this coin versus my other one. And I want to check the value instance field as well as the name instance field against each other. If they're the same, we'll return true. So return name dot equals other name, that is this name. I could write this in front of it. And value equals other dot value. And that will return true if they're all the same. Now I can use equals on the value field because they are primitive types. They are numbers. In this case, doubles, decimals, decimal levels, numbers, decimal numbers. So I can use that, but for the name I have to use the equals method that the string class overrides and knows how to use. And then this would return them if they are the same. The last method we're going to use in the object class is the clone method. And now cloning makes a new object with the same state as an existing one. Now if I made a bank account, X, and made a new bank account, and we'll just go default constructor, no parameters, and then I make bank account Y, and I set Y equal to X, what have I done? Remember, this is that common error from way back in the beginning. In this case, and I say something like Y deposit 500, well, X started out with 0, Y started out with 0, but technically they're the same. So I have two bank accounts, names for the same bank account. I don't actually have two bank accounts here. So I set my object references to go to the same memory address. So I have one object. X and Y happen to technically be tell me where the address is for that. And I just deposited $500 into one bank account. They don't have two bank accounts. If I want to make two bank accounts, I need to clone one of them. That just copies the current state of everything from one to the other. So I can make bank account Y equals, and I have to cast because the clone method is an object. So I need to cast bank account, and I would say x.clone. Call the clone method on X, inherit it from the superclass object, and then cast it to a bank account, store it, and the reference Y tell me to point to that new object. And this would in fact make two of them. They happen to be the exact mirror images of each other at this point, but they are two versus, in the first example, having two names for the same class, or the same object.